In this video we're going to look at bar charts in Altair. We launched Jupyter Lab. That opens in the browser. In the launcher window we click Python 3 and our default imports are always pandas as PD, Altair as ALT. We're also going to import the data loader object from Vega datasets. That's data. From Vega datasets import data. We'll then call the Seattle weather method on data to create our data frame. Seattle weather is a record of 4 years of weather in Seattle, most of which was wet. The marvelous thing about this data set in the current case is that there's a date-time column. And when you have a date-time column, you can break that down into subcategories. So you're going to have 4 subcategories here. We're going to have a year category, which we create by calling a lambda_x function on the date column. So that's x strft time %y, capital Y. We're also going to have a month column, which is it's percent lowercase m for the numerical month. We're going to have 2 day columns. One is going to be the day name column, which we're just going to call day, and that's percent lowercase a. And we're going to have a day of the year column, so that'll be from 1 to 365, and that's lambda_x string format, whatever day the year is. So we're going to look up STRF time, the website, find out what that is. These are all the different formats. Very useful website. And there it is there. It's, what's that? It's percent J. Percent J is day of the year. So Shift and Enter runs that cell. We'll take a look at the top 5 columns, see that they turn out right, and they've turned out perfectly. Now, a bar chart by its nature features categorical data on one axis and numerical data on the other. The problem is, how exactly do we match up this categorical data and the numerical data, in that there will be many instances of numerical data that match up with 1 year. So we've 366 precipitation instances that match up with 2010. Now, Altair out of the box provides us with 6 methods to aggregate this numerical data relative to categorical data. These are mean, median, min, max, count, and sum, which are as you'd expect. So we create our chart as we did before with the scatter charts. We have mark bar this time instead of mark point or mark circle. The x parameter is going to be year, and the y is going to be some precipitation. Close the precipitation is enclosed in brackets there. That's important. This is the sum. We can change sum to mean. That's the mean. We can change it to count as well. And as you can see with count, they all look about the same because there's 3 years have the same number of days, and 2012 is 1 more because it's a leap year. You can just see the slight edge there if you're eagle-eyed. Now, having gone to the trouble of making all those extra categorical details based on date, we might as well use them. So we're going to make a stack bar chart here, which we do by identifying color as month, and that gives us this very groovy, I suppose, chart. Now, Altair by default, it tends to make the charts as small as it can to fit in the screen, and this is obviously a squeeze in this particular case. So one thing that we can do is we can change the x and y axis, which will make this particular chart a little bit easier to read. See, when it goes sideways like that. We're going to look at sizing the charts later in this series, but just for now, you know, this is something to be aware of, that the bar charts can go horizontally as well as vertically. It's a very easy adjustment. Now, with this data set is also suited to line charts. So we're going to look at a line chart now. Again, the syntax is very similar. It's just the mark method, the second method, that changes. We have mark line where we had mark bar, where we had mark point, where we had mark circle earlier, and then we have date and precipitation as the x and y parameters. Now, when we run this, Shift Enter to run the cell in Jupyter Notebooks. This is what they call a noisy chart. There's too much detail on it for the size of the chart. We can change that by slicing the chart so that it only shows us the year. The first year is 2012, so we'll do that. You notice that we're saying 2012 as a string rather than an int, because it's a string format that we called on date to give us the year. These are the little things that you need to watch out for. Else you get these massive error messages, and they're completely frightening. But it's only a simple thing that's wrong. Now, this chart is again just a little unsatisfying. It's just that little bit too noisy. So what I think we'll do instead is we'll go back to the full size data frame, no longer limiting it to year 2012, and instead of date, we're going to look at day of year, and we're going to group it by year. So we have our colors parameter back again, color equals year. And this nearly works, and yet doesn't. And it doesn't because it remains noisy, because so many of the daily levels are so low, and the length of the thing is just ridiculous. So day of the year isn't going to work for us. Therefore, we're going to change day of the year to month and see how we get on then. Just find it here. And we change day of the year to month. Shift and Enter to run the cell. Right, and that didn't work. Doesn't look like anything, and the reason for that is because we didn't call sum on precipitation. And here then is sum. That again, it's not a great graph, but we are able to change mark line to mark area. And that then gives us a much more satisfying, a much more informative graphic. So to make it even more informative again, we're going to add a tooltip. The tooltip, we can't show date now that I think about it, because we've aggregated by month. Therefore, in the tooltip, we'll have to show month, year, and precipitation. So that's what we'll do, sum precipitation, because we sum by month, right? So that's the aggregate that we were talking about earlier. So we run that, and oh god, this is one of the big long error statements that I was talking about. But again, one of the marvelous things about coding is that the length of your error is not the same necessarily as the size of disaster. All I did there was leave out a bracket, and now that I've put the bracket in, everything's working fine. There's our tooltip. We can see everything that we need. It's a beautiful chart. We've come to the end of another of these tutorials. So that's it. Next time out, we're going to look at pie charts, the hated pie charts. We're going to look at box plots, and we'll start digging into the works of Altair a little bit, and see if we can get a little more out of it. It's going to be fun times. Please click like, subscribe, and notify to keep the charts coming. Live long and prosper.